Howdy everybody, welcome back to Lab Hours. Today is going to be the third of the 3 lectures that I am providing as an example for how to teach the lectures I redesigned for the Excel and Stata block of Econ 378 Statistics for Economists at BYU. The first 2 lectures are the Excel lecture, which is nice to sheet you, and the first Stata lecture, which is a blind date with big data. Hopefully you've seen those and have been able to teach those or prepare for those already. This is the third of the 3. This is the second Stata lecture, and I'm calling it, more data, no problems, because we're going to incorporate some slightly more complicated of the basic Stata commands. This one is going to talk about how you have to use different commands to import different types of data files. It's going to talk about the generate command specifically as being one of the funky ones that can trip people up sometimes. It's going to talk about value labels, so like the blue data, and then we'll talk about actually how to do commands in particular if you don't know what you're trying to do. All of these are things they're going to need to do for the second assignment, the second Stata assignment, that is to say. And of course, all the resources for the assignments, the lecture notes, do files that will help you grade the assignments, stuff like that. It's all in the GitHub, all in the link in the description, right? A couple quick notes before I switch into example lecture mode, of course, is going to be that just like the first 2 assignments in this series, I do not think you should have the students follow along with you as you teach. I think they just get behind or get lost or whatever. It's not particularly helpful. However, this second assignment is a little bit more hands-on than the first 2 were. The first 2, the Excel, the first Stata assignment, are a bit more hand-holdy than this second one is designed to be. And for that reason, this second lecture is designed to take about half the time as the first 2. Or rather, it's designed such that the first 2 lectures are meant to take up an entire class period. But this one is meant to take up only about half of the class period so that when you finish this one, you can go around and have the students actually start doing the second assignment. To that end, right, the first 2 lectures, I would argue, do not hold them in a computer lab. It's not necessary. But this lecture, I would argue, hold it in a computer lab because, again, do the lecture, don't have them follow along. But then after this lecture, leave time so that they can start. That is my opinion. Of course, you can go ahead and try and do that however you would like, but that is, from my observations, I feel it will be to your benefit to teach it in that way. The one other thing I want to talk about really quick are the data sets that I have prepared for this example lecture. I have a CSV file here. This is a comma-separated values file. I have a DTA file that is a different data set, but with the same name. And then over here, if I open this one up really quick, I have a data set that is comprised of values that are numeric but labeled as words, and then a couple of other numeric variables. This is, in fact, 1,000 observations from the full count IPM's 1930 census, just 1,000 observations from that. But you'll see I have a variable that has a label with numeric values and a non-numeric label. That's going to be important because, because they'll have one of those that they have to deal with for this second assignment. So we need to familiarize them mostly with just how to deal with labels when they become wrong. So that's all we're going to touch on today, pretty much. So with all of that out of the way, and now that you're prepared basically to give this lecture, if you're looking at the lecture notes, you'll notice they're very short. To that end, hopefully this video will also be fairly short. I'm going to go fairly quick. This is basically to give you an outline of how I would give this lecture, an example if you will, but of course you're going to fill in time with things like asking clarifying questions or like searching for understanding, all sorts of stuff like that, right? You're a professor, you profess for a living, I'm sure. And if you're a student just watching this for the review or because you're having trouble remembering how to do something on the homework, also totally fine. You'll figure it out, it's pretty clear. But let's go ahead and switch into actually giving the lecture mode now, which is going to be very nice. I will every once in a while glance over to the left. That's where I've got my lecture notes, of course. What can you do, right? So let's open up the lecture. We'd say, hello, everybody, welcome back to class, and do all of the things you do when you normally open up a lecture. But basically, let's get into actually talking about what we have to talk about today, which is the fact that there are some loose ends from the basics of Stata that we need to wrap up or tie up for you guys. And the first thing is that at the end of the last Stata assignment, the students have actually saved a .csv file. It should be called Data for Obama, if my memory serves correctly. And one thing they may have noticed is they may have tried to open it using a use command, but that it didn't work. And so we're going to talk about that today. Let's talk about, for example, why and how Stata has so many problems opening different types of data sets. So the first thing I'm going to do is I'm going to open up Stata. Right, here it is. We love Stata, beautiful Stata. And what I'm going to do is, of course, I'll throw back to last lecture where we look at our directory, and I say I want to use one of these files. I want to use this file right here. And I'll open it in Excel. This is a comma-separated values file, just like the Data for Obama one. And you can see we have a couple variables in here. We've got things like FIPS, PID depth, stuff like that. This is from match rates for crosswalks for stuff from the Record Linking Lab. And if you're interested in that, you can send me an email at labhours@teamwork.org. But for now, we just need to know this is what the .csv should look like. This is what the data set should look like. It has FIPS, it has HistArc, all sorts of stuff like that. We'll just keep that in mind. Now what I'm going to do is I want to use this file right here, this county match rates file. So from last lecture, I know I need to change my directory. So I'm going to go to my change the directory from the documents folder to the desktop folder. I'm going to go c/users/morgantoe/desktop, just like from last lecture. And now what I'm going to do is I'm going to use county_match_rates. That is what the file is called. And I'm going to go take a look at the data that's loaded up. And I'm going to notice this looks very different from the data set that we have pulled up here in Excel. And in fact, if we compare them, we can see that these are clearly not the same data sets. What was the problem here, is what I'll ask. Well, let's recall for a moment, let's full screen and minimize that. Let's recall for a moment that Stata is very kind, but it's also very shy, which is to say it does not want to make a mistake. And one important thing about Stata is how it brings data into memory. It has to do it differently based on the type of file it's trying to bring into memory. So for example, this file right here that I may or may not have pointed out to the students beforehand, depending on how I feel during the day, this is a .dta file. This is a Stata file with the name county match rates. And in fact, this is actually the file we have opened when we used the use command. The interesting thing is that Stata has to deal with these different file types differently because they store data differently. And if I want to throw back to the Excel lecture where at the end we briefly talked about the difference between the Excel file .xlsx and the comma-separated values file .csv, I'll remember that the .csv is basically a glorified text file. It's just like variable, comma, comma, enter, right? But the Excel file is way more complicated. It can store things like graphs and all sorts of stuff like that. So because they're different types of files, Stata actually needs to perform different processes on them in order to bring them into its memory effectively. So this is one thing to know, is that if you are having problems bringing a file into Stata, this is what you do. You type help import, okay? This entry provides a quick reference for determining which method to use for reading non-Stata data into memory. This is a super helpful thing. If you have an Excel file that you need to import, you import Excel. Now this can be deceiving because this right here comes up with an Excel option, but if I hover over it, it will tell me this is a Microsoft Excel comma-separated values file, which means it's not actually a native Excel .xls or .xlsx file. It is a comma-separated file. And we'll notice right here, import delimited reads text delimited files. In a comma-separated or comma-delimited values file, the comma, where it goes value, comma, enter. Value, comma, enter. That comma is a delimiter. That's the word for it. So we have a comma-separated values file that we'd like to open. So instead of using use county match rates, let's clear what's in the data set, and we will do import delimited using county match rates. And now when we go to the browse, we will see this looks pretty much exactly how we expected it to look. This is the correct file to use. So if any of the students had tried to open data for Obama using a use, I would have been like, did anybody try to do that? And what happened? I would have asked them, right? It didn't work. I wonder why it didn't work, you know? This would be why. So that's going to cover everything from import. Again, if you need help bringing a file into Stata and it's not a Stata data file, help import and find the one that matches best, okay? And a special caution, of course, for comma-separated values file, because they are very common when you're downloading data from government websites or stuff like that. You will frequently see tab or comma delimited files, something to watch out for. That will basically wrap that up. I'll clear everything from memory, and I'll just say, well, okay, now let's say hypothetically we're writing a do file, okay? And as they know, they've looked at a do file from last assignment. They've written all of their answers into one, right? And so what I would say to them is I would say, okay, what if I'm writing a do file and I want to open a new file, but it's in a completely different directory, but I also don't want to change directories because I want to save a file to the same directory or something like that. Maybe what if I want to open a file, but I don't want to have to worry about what directory I'm in? Well, then one thing I am going to show you is this really cool little tip. If you're on Windows and you just want to get the file path, which is to say, instead of setting the directory, which is to say Stata, look in the desktop drawer of the Morgantoe drawer of the users drawer of the C filing cabinet, right? Instead of doing that and looking for a file called county match rates, what if I just want to tell it, get this file from this folder, from this folder, from this folder, from this place, right? What that would be is a file path, the direct location of the file with the file's name. And one really easy way to get that, I mean, I could open up the File Explorer, right? And I can come over here to my desktop and I can say, okay, I click up here, but it's not like sometimes on like older Windows, it will show you your like whole directory here. Sometimes it just says desktop. Like it's kind of annoying, right? The thing I recommend, if you're on Windows, if I right click this, it gives me options to like open with, it gives me options to like send to, copy, delete, all sorts of stuff like that. You could always open it with Stata, that'd be fine, but it's not very helpful for like a do file when I want the file path. If I want the file path, I'm holding Shift now. If I hold Shift and I right click this file, there's an option there that wasn't there before, which is copy as path. Let me show you that it wasn't there before. It was right in between these two. And now if I hold Shift again and right click, copy as path. What that does is it gives me the string, let's say use, boom. That is the direct file path, the direct path to that file on my computer. And if I hit enter here, and in fact, let me just show you, if I change my directory so that I'm not even looking in the desktop anymore, now I'm just looking in the user's file, for example, right? I'm not looking at the desktop at all. If I were to just type use homes 30, which is this file that I'm trying to use right now, it would say I can't find it. But if I did use the file path to homes 30, Stata finds it instantly. And you can see I've got a data file open right here. So that's a nice little shortcut that I think is helpful. If you're on Mac, by the way, and I will show you this really quickly by coming over here to my desktop, if I right-click a file and click the Option button, it doesn't normally flip like that, but let's say I right-click, it gives me this menu right here. If I just click the Option button, which is next to the Command button, this copy countymatchrates.csv as path name, same thing, except it doesn't give you quotes, so you'll have to add quotes to it. For those of you who have to teach on a Mac, potentially, this is the helpful thing here, right? Copy countymatchrates.csv as path name, okay? Let's make sure that I switch back to the remote desktop, and let's get back into it. So that's that nice little shortcut. We've got a data set in memory now that we want to play around with. And this, in fact, is a data set. It is 1,000 observations from the 1930 IPMS, from IPMS version of the 1930 full count US Census. And I've kept 3 variables from it. I've kept the state that the person was living in, whether or not they owned a home in 1930, and the person's birth year. Now, I mean, I calculated birth year by doing 1930 minus their age in 1930, which is actually what's written on the census. But so this is person one. Person one lived in Illinois, did not own a home, and was born in 1912, right? So one of the nice things about Stata is that we can make little markers, or we can mess with these variables in all sorts of fun little ways, okay? And the way that we do that is sometimes by replacing the variable or recoding its values or whatever. But other times, we do it by just creating new variables whole cloth, right? And one of the really nice things about Stata is how easily it creates those new variables. The command to do so is called generate. And generate is kind of a finicky command, which is why we're going to wrap it up today, right? Generate creates new variables, okay? These square brackets, of course, are optional things. The thing that is important from this syntax, generate a new variable, you'll name it here. This bold equals sign means it has to be typed every time you do a generate. And then an expression. There are some options. You can do ifs and ins, totally fine. But the main thing to take away from it, for example, let's say I wanted to create a variable that was just the number 7. Like say this is my 7th sample, so maybe I wanted to generate a variable called sample number. A single equal sign, because it has to be there, and then in this case the expression, I just want the value of the variable to be 7 for every observation, because maybe, for example, this was the 7th sample I took from the census or something like that, right? If I hit enter here, we get a new variable, sample number, and I can actually shorten it and it will abbreviate itself, which is kind of nice. But it's just 7 in every row. Every observation has a 7. This was the number of the sample, right? So this expression was just give it 7 in every observation. Let's drop sample number, which you can abbreviate, which is pretty cool in Stata. Let's say, for example, instead of just generating one that is just a normal number, let's say I found out that everybody's birth year was off by 1. Like instead of 1912, the person actually was born in 1911, because maybe the census was carried out on like December 25th of 1930. And so practically everybody is like actually born a year earlier or something like that. I'm not sure if that even works out mathematically. Just off the top of my head, what I can do is, instead of messing with birth year, if I want to leave the original one there because I have old code that calls it, for example, and I don't want to mess with that, but I also want to use like a fixed version of the variable, I could generate, or just type gen. One interesting thing about generate is that, hold on, there we go. One interesting thing about generate is that you can abbreviate it down to just the G, which is what this little underline that's kind of hidden is denoting, right? Whenever you see an underline on a bold thing in a command, that's what you can abbreviate that part to. So this option can be abbreviated to like B parentheses var name. Generate can be abbreviated down to just G. You will see gen a lot, in my opinion. Well, from what I've seen, that is to say. Maybe I want to generate, for example, birth year fixed. And I want that to be whatever the current birth year is minus 1. Take a look at that. That's crazy. What is this doing? Well, it's going down the list one by one from the top observation, that Illinois observation, and it's taking the value of birth year, the numeric value of birth year, in this case 1912, and it's subtracting 1, and it's placing it in birth year fixed. And you can see that it's called birth year fixed if I expand that a little bit, right? Generate birth year fixed and make it so that it's the value of birth year in its corresponding observation, but subtract 1. And you don't even have to do this with any numbers. You can do this entirely with just variables that already exist. So if we did, for example, gen fix check, maybe I want to make sure that birth year fixed was correct, and so I make that equal to birth year minus birth year fixed. That should be 1 for everybody, right? And so maybe I'll hit enter there, and as long as it's 1 for everybody, I know that, like, birth year fixed works. It's 1 different, right? But the point here is not that, like, to come up with the reason for why I might need this variable, but just to show that like these variable names in the generate thing, they turn into the value of that variable in the observation, right? So for the first observation of fixed check, birth year becomes 1912 and birth year fixed becomes 1911. For the second observation of fixed check, birth year becomes 1922 and birth year fixed becomes 1921, right? So that's how these expressions kind of work. Now that is like a mathematical expression, an arithmetic expression or something like that. Let me drop birth year fixed and fixed check just by their abbreviations. Maybe instead of just doing arithmetic expressions like add 1 or multiply by 10 or take the square root, maybe I also want to like do a logical expression. So maybe I want to create a binary variable or a dummy variable. And in fact, you can see that own home 30 already is one of those. But maybe I'm only interested in the people who were young in 1930 who owned a home. One particularly interesting one is this person who is 8 and owns a home, but I think that's just from the home owner, which is kind of funny. Funny the way that they keep that variable. But let's say I'm just interested in maybe the people who I think are too young to own a home in 1930. So maybe what I could do is I could do generate a variable called too young. And I want that to be equal to a logical expression. And here's what I want that expression to be, okay? I want this to turn into a 1 if the person is born like before, if the person is born after 1914, which means they are younger than 16 in 1930, and they own a home, then I want this to mark them with a 1, because I know that those people are probably wrong. They're a problem with the data, potentially, right? So let's generate too young is equal to a logical expression. And this one is going to be a fairly complicated logical expression. And we remember from last time that logical expressions are things that can be true or false for a given observation. The first stipulation of our logical expression is that birth year needs to be greater than 1914, okay? So this is anybody who's 15 or younger in 1930. If they were born in 1915 or later, they're too young to own a home in 1930, in my opinion, right? Just for the purposes of this. But not only does that need to be true, I need it to also be true that own home 30 is defined as the value of 1. Now let's talk about this for a second. This is an important distinction that trips a lot of people up. This equals sign here is just straight up part of the generate command. It is almost the only time you will ever use a single equals sign in Stata from my personal experience, doing research work, teaching, all sorts of stuff like that. As far as my memory is serving me right now, which don't super quote me on that, but this equals sign is coming directly from, let me just cut this really quick. This is coming from the help generate file, right? This equals sign is bold here. And what it's doing is it's saying, tell me the rules of this variable too young that you're trying to generate. Tell me its rules. When the rule that comes after the single equal sign is a logical expression, that means that too young is going to be a 1 when the expression is true and a 0 when it's false, okay? So in this case, if a person is both born after 1914 and owns a home in 1930 with this and sign, they will get a 1. So we should see a 1 in the second observation. But we should not see a 1 in either of these observations, right? Or in any of these, because either own home 30 is not equal to 1 or they were born, before 1914. This double equals sign, like we talked about yesterday to an extent, is the logical check for equivalence. Is own home 30 actually directly equal to 1? Is it defined as 1 in this observation? So single equals the rules for a variable. Own home 30, double equals 1. The other times you'll use single equals are like in specific commands, like maybe a recode command or a replace command. But again, replace just comes up as part of the help file, right, for generate. If you're using replace, you'll use an equals sign. Absolutely. Okay, so just keep that in mind. Single equals the rules for something. Double equals a check for something. Okay, so I'm going to hit enter on this binary variable. Again, too young should give me a 1 if the person is both born after 1914 and owns a home in 1930. And basically what we were looking at is exactly right. We see a 1 here, we see a 1 here, and the only people that we see 1s in are people who own a home in 1930, they have a 1, and were born after 1914. Okay? Great stuff. Now, again, did I clean these variables specifically for this example? Who knows, right? You'll never know. But this is just to sort of teach the generate command, some of its intricacies. You can just put a normal number. You can put variables mixed with numbers. You can put variables mixed with variables arithmetically. You can put in logical expressions. That's everything you need to know about generate for the purposes of this class, okay? So this binary variable that we've just made is pretty cool. It gives us an indication of something we think is weird about the data. And this in particular is one of the strengths of Stata. Trying to do something like this in Excel is a little bit obnoxious, especially if instead of 1,000 observations, you had 1,000,000 or 120 million, like we have in the 1940 census, for example. So that's going to cover generate. And now one other thing that we need to talk about, and we're just going to mention very quickly, is the fact that you may have noticed that this column right here, state ICP 30, ICP is just a code. It's a numeric code that identifies a state. So, for example, I believe that California is 74 in the ICP coding. But you'll notice state ICP is blue, and it has the names of the states. Well, what that means is that these values have actually been labeled. That is what the blue color means. You remember from last lecture that the black means number, the red means string, and you might have been looking at this the whole time and going, well, these are definitely not numeric characters. Why are they not red? The reason they're not red is something kind of sneaky. If I click over here on birth year, 1912, 1922, 1897, you can see up here in the top, value is what just popped up under my mouse. The value of that observation, I'm just using the arrow keys now, is exactly what you're seeing. With a black numeric variable, the value of the observation, this person was born in 1915. The value is the numeric 1915. Same is true over here for too young, 0, 1, 0, 0, 0. You can see it change up in this top bar. This top bar tells you what the value of the observation is. If I come over here to state ICP 30, the reason this is blue and not red is because when I click on Illinois, the actual value is 21. So what is in this box is not actually Illinois. What is in this box is the number 21. Same with Louisiana below it. What is in this box is not the word Louisiana, like we saw with the string variables from the last lecture, right? Those are red. The true values of those would have been Illinois, Louisiana, those characters. But this data has been labeled, okay? And what that means is that the underlying value is 45. So for example, check this out, right after I sneeze. Thank you, pardon. What if, and hear me out, what if I took this 45 value and I changed it to 21? What if I replace state ICP 30 and I make it equal to, what was it? 21 in 2. In 2 means in the second observation. Louisiana right here, this is the second observation. You'll notice it's 45 right here. And what I'm going to do is I'm going to change it to 21. Now I want you to take a wild guess what will happen, is what I would ask the students, right? What do you think would happen? And then I'm going to hit enter, and look, it's Illinois now. Holy cow, that's crazy. Labels take values of numeric variables and attach words to them, or they basically put a sticker on it. And those stickers are assigned to specific values. So if you change the values underneath a label, those labels also change. So for example, what if I just replace state ICP 30 with state ICP 30 plus 1. This replace, of course, coming from the generate command, right? All of these are going to change. And some of them aren't even actually states anymore, right? These labels are wrong now because we have modified the data underneath them. So if I get to a point where I have variables that are wrong, for example, like this one is just state not identified. Cool stuff. What do I do with that? Well, maybe I want the variable labels, the value labels, to go away. I want them to go away. I don't care about them anymore. Well, then one thing I'm going to do, label values state ICP30 the missing value. What this is going to do, and you can do help label if you'd like to get more information on this, but this is everything they're going to need for the assignment, because basically they're just going to recode a variable that is labeled. It will make the values incorrect, and then they'll have to like deal with that a little bit. They don't have to, but it's like it's nice to, right? I'm going to label the values of the variable state ICP30 with missing, which is to say I want the value labels to no longer be there. So let's run that. And you can see it has returned to us just the number. 14 for 14, 34 for 34, and so on. That's the fun, confusing thing about labels here in this case, right? So watch out for that. If it's blue, it's labeled. So you can find the true values up here in the bar, in the browse window, and so on and so forth. The one other thing that I think is nice, if I go to labels, no, hold on. I want to put the labels back on really quick. Label dear, I was close. Label directory. That label was called state ICP underscore label. So if I wanted to put them back on really quick, this is an interesting thing that I think is helpful really quick. If I go label values state ICP30 with the state ICP underscore label, it will bring it back. And then maybe if I go back and I say replace state ICP30 is equal to state ICP30 minus 1, because I added 1 a second ago, it's going to fix and go back to what it was before, which is really nice. The one other thing I would show that's in conjunction with labels is if I were to do a tabulate, a tab command, on state ICP30. It gives me this table, and actually let me extend the screen a little bit and rerun that command. It gives me this table of all the values and how often they show up. So Connecticut shows up 9 times. South Dakota shows up 6 times. If I were to do a tab, you can abbreviate this as tab. Tab state ICP30, but with the no label option, it gives me the same exact table, except the labels are gone now, which is nice. Connecticut had 9, Maine had 12. Well, state code 1 has 9 and state code 2 has 12. That can be useful for determining something like what are the actual values underneath the labels without having to go into the browse window and actually click on all of them like we did. So like we know that New York is 13 from clicking on it and seeing it, but we can also know by saying, okay, New York had 114 people in it. Well, state code 13 also has 114 people in it, right? So that's something fun to keep in mind with labels and tab as well. It can be kind of nifty to play around with. I think that's already on the assignment for them, like the tab and tab no label hint I think is already on there, so nothing crazy. The one other thing that we want to do is, let's say you wanted, for example, to find the correlation between a person's birth year and whether or not they own a home, right? And as a teacher, what you're going to do is you're going to pretend to not know a command. And specifically, we want you to not show them the commands recode and rename, because the assignment is going to ask them to Google and find commands that will do what recode and rename do, right? So you would say, as I'm lecturing, I would say, let's say, for example, I wanted to find the correlation between birth year and own home 30. But for the life of me, I cannot think of a command that would do that. Well, what I'm going to do is I'm going to go to Google, and I'm going to open it up, and I'm going to type in find correlation of 2 variables in Stata. Enter. And what's going to pop up is something helpful, I think. Correlation, Stata help read college. Correlation is performed using the correlate command. If no variables are specified, Stata will display blah, blah, blah. It has given me a command I can look at to see if it will do what I want it to do. So let's come over here and do help correlate. Correlations of variables. That sounds like what I want. Display correlation matrix or covariance matrix. That sounds like something interesting. Let's try correlate own home 30 and birth year, right? Because if I pull up the help menu I was just looking at again, it gives me correlate var list. That means I can put in a list of variables that I want to try to correlate. So let's try that. And this is really interesting, right? So clearly, here's one hint on reading these, right? Own home 30 and own home 30 clearly have a 1 correlation coefficient. As own home 30 goes up by 1 standard deviation, own home 30 also goes up by 1 standard deviation. Same is true with birth year and birth year. But the really interesting thing is that if own home 30 goes up by 1 standard deviation, birth year goes down by about 1/10 of a standard deviation. That is what the correlation coefficient is. This is the correlation between own home 30 and birth year. So as a person's birth year gets bigger, their likelihood of owning a home gets smaller in this data set, which makes sense because the bigger their birth year, the younger they are. So, you know, you can remember, in the lecture notes I have to show, in the lecture notes I suggest that you also do the same pretend not to know the command with like the summarize command or like summarize detailed option for finding like percentiles and stuff. But you can pretty much throw whatever you'd like into there. The basic idea is show them how to Google things, which is to say, figure out what you want to do. Find correlation of 2 variables in Stata, or even something like command to find correlation in Stata. And then just go looking. Find a command, any command, throw it into help, see if it'll do what you want it to do. That's sort of the skill that we're looking for here. The assignment is going to ask them to do this, and explicitly do not show them recode and rename. That's in the lecture notes. You'll see that because those are the ones of the lecture that the assignment is going to actually have them find. Now, if you're watching this for help with the assignment, congrats. But it also means you probably have the skills that you would have needed to find them anyway. So, good stuff. As a student, that is to say. That covers everything from the lecture. This is the point where I would say, you guys have everything you need now to do the second assignment. So we're going to break, log onto your computers, open up, download the files and stuff that I've put on Learning Suite or wherever the central, like Canvas or whatever. I've put all the files on Canvas, so go get the files and start the second assignment, the second Stata assignment, that is. And I'd walk around and I'd say, are we all getting this? Does this make sense? Do you need help with this, right? All sorts of stuff like that. So that is the second Stata lecture. Thank you much for watching. Again, if you have any questions, suggestions, tips, whatever, you can email labhours@teamorg.org, or you can just leave a comment on the video. I'll answer either way. The other thing that's nice is if you would like to use these assignments and lectures and stuff, all of the materials to do so are in the link in the description. They are at the GitHub link in the description. You have teaching notes, you have the assignment files, you have template do files, you have the actual data files they'll need to use, you have do files that will grade their submitted do files and stuff like that. All that stuff is down there. If you want to use it, go for it. The one thing I ask is that you subscribe to the channel and like the video. Because that will hopefully allow other people to find the same resources and find the same sort of utility out of them that you are. So thank you so much for watching. Again, all of that, questions, you know where to send them. Comments, I'll answer. Likes, shares, subscribes, appreciated. Thanks so much for watching these 3 little lectures. Hopefully you can find some good use for them in your classroom, or if you're a student in a classroom where these lectures are being used, hopefully this was a lovely review for you. So again, thanks so much for stopping by Lab Hours. I'm Tommy. You already knew that. Have a wonderful time. Hopefully we'll see you around in some of the other videos on the channel. Thanks so much for watching. Have a good one. Bye-bye.